Greetings, students. This is the second set of notes about rocks in the Rocks and Minerals unit. It's called ES 5.2, the rock cycle. In these notes, you're going to write down everything that's in orange text. And you can pause the video if you need more time. At the very end, there will be a catch-all slide with all the information you were supposed to write down. The rock cycle is a model of geologic processes, that means rock processes that cycle matter throughout the geosphere. So the geosphere is like all the rocks on the planet. And here's a picture of the rock cycle, or a diagram rather. It shows the three types of rocks and how they move from one form to another based on different processes. And we'll be drawing this repeatedly. Here's another version of it. There's all sorts of versions of it online. This one doesn't have any words though, but you can see some melting rocks and some different rock types, some weathering and erosion is happening. So rocks always change. They change really slowly. Rocks that are igneous today could be sedimentary or metamorphic at some point in the future, only to become igneous again later on. So it's a constantly changing thing. It's just happening mostly very slowly. The rock cycle is happening all the time, recycling Earth's materials again and again. All rocks are formed and reformed through this process, for the most part very slowly. For example, it could take hundreds of millions of years for a mountain range to be completely eroded. Or some examples of geologic events happen very quickly, like a volcanic eruption. But for the most part, the rock cycle is happening pretty slow. Here's a picture of a volcano taken from outer space. Pretty cool. So remember, there are three types of rocks from the last set of notes. You've got igneous, sedimentary, and metamorphic, and they're defined by how they form. And any one of these rock types can go through changes to become another rock type. So just because a rock is sedimentary right now doesn't mean that those particles will be part of a sedimentary rock in a million years. Taking a closer look at this diagram, all rocks that are metamorphic, they have heat and pressure that makes them metamorphic. All rocks that are igneous have to become molten rock, which can also be called magma or lava first. So if any type of rock melts, it turns into magma or lava, and then it crystallizes into igneous rock. And likewise, any rock can be weathered and eroded. If it's igneous, metamorphic, or sedimentary, if it's exposed to the elements, it's going to experience weathering and erosion. Weathering and erosion turns rocks into sediments, and after they are sediments, they become compacted and cemented into sedimentary rock. So melting followed by cooling and crystallization can turn any rock into an igneous rock. Here's a diagram of that process. Weathering and erosion, followed by compaction and cementation, will turn any rock into a sedimentary rock. And those sediments are carried by the water cycle to large bodies of water where they're deposited, compacted, and cemented again. Cementation is just a fancy way to say stuck together into layers of sedimentary rock, and the key is increasing pressure. Here's a picture of a big boulder that got split in half. That's an example of weathering. Probably some ice involved in that process. Heat and pressure, or chemical action, can change any rock into a metamorphic rock. So you've got a rock that starts out with randomly oriented minerals, and then after metamorphism, sometimes you get these stripes or foliated lines in the rock. There's an example of a foliated metamorphic rock. It has stripes or bands of different minerals. The minerals separate themselves by density during the process that make it a metamorphic rock. So an important question to answer here is, if all the rocks are moving and changing very slowly all over the planet, where does the energy come from that causes these transformations? It's a good question. A big driver of the rock cycle is based on the theory of plate tectonics. That's the first answer to the question, where does the energy come from? Plate tectonics. And that topic has its own dedicated unit. Long story short, the theory states that the Earth's lithosphere, which is the crust in the upper part of the mantle, is divided into sections, and those sections are constantly moving. You can see a picture here of the Pacific plate and the North American plate, the Eurasian plate, the South American plate. They're moving and rubbing against each other. The energy that causes the plates to move comes from convection in the Earth's interior. That's when warm materials rise and cooler materials sink. The convection's happening in a layer called the asthenosphere, which is the malleable part of the mantle, the part of the mantle that can move. But convection happens anytime you have fluids of different densities. Convection happens in the ocean, it happens in the atmosphere, it happens in a pot of boiling water. The hottest water rises to the top and the coldest water sinks to the bottom. The asthenosphere is not completely liquid, but it's malleable and it exhibits flow. Sometimes it's called a plasticky kind of flow. Warm materials that are less dense than cooler materials. So the warm materials deep inside the Earth's interior rise, while relatively cooler materials that are closer to the surface sink inward. So here's an example of water on a stove exhibiting convection, and then right next to it in a diagram of the mantle, or the asthenosphere, exhibiting convection that causes the tectonic plates to move. It causes a circular motion that drives plate tectonics. As the tectonic plates move around, they smash against each other, causing rocks to move and change. And that's part of the rock cycle. This is interesting. So all the red dots on this diagram are active volcanoes, which occur near plate boundaries. So where there is magma rising to the surface, that's usually where two plates are meeting, or it could be at a hot spot. So Hawaii is considered a hot spot. An area called the Ring of Fire is the area surrounding the Pacific Plate. The Pacific Plate is called that because it's under the Pacific Ocean, and the boundary of the Pacific Plate has tons of volcanoes, and it includes New Zealand, Indonesia, Japan, Alaska, the west coast of the United States, and that's called the Ring of Fire. The second part to the answer of where does the energy come from that moves the rocks around and changes the rocks is going to be answered now. So part two of that answer is another part of the rock cycle is weathering and erosion. Any rock can become sedimentary if it is exposed to the elements. Rocks are weathered and eroded by wind, water, and organisms. The sediment is transported by stream to large bodies of water and deposited. Here's a picture of the Susquehanna River. Well, actually the Chesapeake Bay, but the Susquehanna River is notable here because look at all that sediment. That tan color of the water is all the sediment coming from Pennsylvania and New York and traveling down to Maryland and Virginia through the Chesapeake Bay. You can also see the James River here. The James River is at the bottom. It also has a fair amount of sediment. So think about all of that dirt, dust, silt, and clay that travels through these large rivers to the Chesapeake Bay. It's really an enormous amount of sediment. And if you're ever crossing a bridge and you see, the water, sometimes it looks different. Sometimes it has this kind of chocolate milky color. That is sediment floating in it. And I suppose this person is going to measure something about the water. So the motion of wind and water on the planet is caused by the sun, which drives the water cycle and weather. So where does the energy come from the water for the rock cycle? It comes from plate tectonics, and it comes from the sun. Here's a diagram of the water cycle. We'll be taking a closer look at the water cycle in a separate unit. But the water cycle and the rock cycle are intertwined. Another important thing to consider when you think about the rock cycle is the law of conservation mass. And that's a physical science topic, but it's important here. The law of conservation mass states that matter cannot be created or destroyed. So you can't just make an atom out of nothing, and you can't make an atom go away. So rocks can be melted, crushed, eroded, ejected out of a volcano, metamorphosized, but the atoms that make up those rocks, they never disappear. So we have a rock cycle where the rocks are moved and changed, but the materials that make up those rocks are never destroyed. And here is the final slide with everything you needed to write down for this set of notes. So you can pause it here and catch up on anything that you missed. And that's the second set of notes on rocks, the rock cycle.